Welcome back. This is an Aleks training video on calculating the pH of a strong acid solution. pH is the concentration of hydronium, which is H3O+. And anytime that you put a strong acid in water, it's going to completely dissociate. So HBr here is a strong acid. There are 7 strong acids. HBr, HCl, HI, then chloric, HClO3, perchloric, HClO4, sulfate, H2SO4, and nitrate, HNO3. So that is from memory. You have to know there's 7. So this one is a strong one. It completely breaks down, and so when the hydrogen comes off of this bromide, it's going to join itself to a water molecule and become hydronium. The pH is simply the concentration of that hydronium. That's all the pH means. So, first thing I need to do is write this out. Here's the equation, and I have to balance it because I have to know what the hydronium is first, and then I can end up. But I have to know hydronium based upon how much hydrobromic acid that they're giving me. So I need to know that it's a one-to-one relationship. So you have to balance the equations first step. So now I need to know how many moles, since this is a number 1 to 1, I need to know how many moles of hydrobromic acid I'm starting with. So I'm given that it's 631 milligrams. Okay, if you remember, I need to go to moles, so I have to go to grams first because the periodic table is in grams per mole. So I know that there are 1,000 milligrams in a gram. Milligrams cancel. That means it's going to be 0.631 grams. Okay, so this would be of HBr. And I have to divide by its molar mass. So I go to the periodic table, find hydrogen and bromine, add them together. And this is 80.912 grams per mole. Grams will cancel. I'm now in moles. 1 second. 0.631 divided by 80.912. I have 0.007798596 moles of HBr. Okay, the moles of hydrobromic acid really don't help me yet because I need to know what are the moles of the hydronium. It's the hydronium that is the pH. I want to find the pH, so I need to find the concentration of hydronium. But I need this in order to go through the balanced equation. This is a 1-to-1 relationship. That means that 0.007798596 moles of this equals the same number of moles over here. All right, so that means I'm going to get the same number. I'm just going to recopy it here. So it's 1 mole, I'll show it to you, 1 mole of HBr is to 0.07798 moles of HBr as 1 mole of H3O plus is to the same 0.007798 moles of H3O plus. So if we know the moles, how do you find the molarity? Because remember, the molarity is the concentration. So molarity is moles over liters. All right, so I have moles. So let's say molarity is 0.007798596 moles over how many liters? Well, 180 milliliters up here. So I need to do that in liters. So it's going to be 180 liters. So that gives me the molarity equals 0.043325533. Okay, the molarity of the H3O plus. Well, what's the next step? You're going to need to find its pH. I've got the molarity of it. What's the pH of it? Okay, so there's just one more step. The pH has a definition. pH is equal to the negative logarithm, base 10, so it's log on your calculator, of the concentration of the hydronium ion, which is your molarity. Okay, your molarity is the concentration, so it's going to be the pH negative log of 0.043325533. So I put that in, I push log, then I push negative to take it off, and you'll see that the pH is 1.363256082. Now, how many significant digits are we talking about? Okay, we've got 3. Okay, there's 3 significant digits here. Okay, and there's 3 significant digits here. So you remember something a little weird you have to remember in pH. The significant digits have to be the digits after the decimal point on a pH. So if I have 3 significant digits here and 3 significant digits here, I have to have 3 places past the decimal. Okay, so this is going to give me pH equals 1.363. And that's the pH if you put 631 milligrams of hydrobromic acid in 180 mils, up to 180 mils of solution. You can find the pH of anything. So, pretty good problem, I think.